Yeah, that's correct.
Good evening, all. Welcome to our AF Mixer. We've got a one topic on our agenda for a short presentation. So that'll be Charlie. He's going to be talking to us about basic grounding considerations. And before we get to that, though, I just want to welcome you all, of course, and give you our standard disclaimer is that please be aware that our meetings are recorded and made available for the public viewing on our YouTube channel. By participating in this meeting, it's understood that you've accepted these terms. So, and again, as usual, please keep your mics muted unless you're actively speaking, minimizes background noise and distractions. And without further ado, we're going to move to Peter, who has an announcement to make prior to getting into the business part of the meeting. So go ahead, take it, Peter.
Okay, thanks, Eric. Okay, I
Yep.
was talking to Frank just before just about a half an hour, 45 minutes ago, and he asked me to pass on the news. He's had some TIAs a few days ago, so he's not feeling all the best. He's got a 24/7 heart monitor around him, hooked up the Bluetooth, 24/7 monitoring, all that kind of stuff. So, but otherwise, he sounded like the old Frank, but just a little bit tired. But anyway, he asked me to pass on the news, so he seems okay. But I guess we'll see what happens.
Just in case anyone needs translation, right? Transient ischemic attacks. So
Oh yeah, it's like a little mild.
it's
Throat
it's
flu, isn't
it's the equivalent of angina, to a heart attack. Essentially,
Yeah.
as TIA is like a mini stroke,
Yeah.
essentially. So, yeah. All right.
Anyway,
So,
that's all I've got.
yeah. All right. And as it happens, I'm probably going to be seeing Frank next week. We're going to be in his neighborhood, Sandy and I. We're going to see a concert just across the border in Detroit. It's Jeff Lynne's ELO Over and Out tour. So, and Frank has graciously agreed to host us in their guest quarters. So I will be looking forward to that, and hopefully he's doing well. I just got news of that as well. He sent me a message this afternoon. So anyway, we'll hope for the best for Frank for a continued health and a speedy recovery. So. Anyone else have any significant announcements or emergency traffic for our AF mixer? Doesn't look like it. So, all right. We will have our usual roundtable where we'll go around the screen and talk about what's going on in our, shacks, benches, and anything else that's significant. Racing setups, whatever you want. Maybe we'll get to see a lap from Hassan if you can tee that up while you're in the background there, Hassan. So
If I can finish one without crashing.
all right. Okay. So, Charlie, if you're ready to go, then take it away.
All right. Thanks, Eric. I'll see if I can share my screen here. What did I just do? Screen sharing. This is interesting. Entire screen.
Always is with Jitsi.
This one. Yeah, the interface has changed yet again.
Yeah.
All right. So you should be seeing all of you. And I will just start my
Yep. We see your
PowerPoint
grid.
full screen. How's that?
And there you go. Perfect. You got full screen on your first page.
Excellent. All right. So when it comes to grounding and bonding and so on, this is probably the deepest rabbit hole I've ever come across. There are more opinions and bits and pieces of data out there. It's most hams consider this to be black magic. I guess it's worth stating before I dive into this that in my career, I spent a fair amount of time designing telephone interfaces to the outside world with those lines that run down the side of the road and so on. So, lightning and power cross and other nasty things in that environment gave me an introduction to grounding in a big way. But when it comes to RF stuff, it becomes even more complicated. So, why would we worry about grounding anyway? How important is it really? I mean, the primary considerations, obviously, operator safety. We have to deal with things like lightning, direct hits, and even hits nearby will cause a fair amount of current in your antenna system. Power cross, where an antenna accidentally hits a power line or something of that nature. Given a storm and the size of most folks' lots these days, that's more common than we'd like to think. Equipment failure, especially tube gear, can cause high voltages on the outside of equipment. So if it's properly grounded, not a safety concern. However, if it's not properly grounded, you can be in a fair amount of trouble. And speaking of equipment, of course, there's a whole question of equipment damage from things like power cross and lightning strikes. The ground will actually bounce. We'll talk about that in more detail, what that means and what happens in a couple of minutes. And just a differential voltage between grounds, how that might happen, and so on. We'll talk to that as well. But ignoring the safety aspects for a second, from a radio perspective, radiation and electromagnetic compatibility, you can get into trouble with your equipment, things like computers resetting, radios misbehaving with extra noise and so on. And of course, then it comes down to problems with your neighbors where you're interfering with not so much their televisions these days. Not too many people watch broadcast TV anymore, although there still are a number of folks. But you can cause trouble even to folks who are streaming video if the fields that you're creating are strong enough. In terms of your actual operation as well, for the receiver, the noise. Noise floor is always a problem when you're trying to hear those faint, distant stations. If you don't have a good ground, you can have things like static discharge noise. A little bit of breeze across the antenna will create static electricity. It builds up, then arcs over, makes snaps and pops, which all make your signal sound terrible. Signal, of course, is always in reference to something, and so you want something that is relatively clean as a reference for your signal in order to be able to do things. So bottom line here, grounding is absolutely critical for performance. It's critical for safety, and sometimes the safety and sometimes the RF performance, those things are at odds with each other. A solution that's better for one might not necessarily be better for the other. So let's talk about protection first. No matter how great your grounding system is, a typical lightning strike is on the order of 30,000 amps of current flowing. Massive numbers. So if you have any kind of resistor, resistance to ground, and there will always be something, you're going to get a volt drop across that resistor. So even if you've managed to get everything perfect and you've got your resistance to ground down in the sort of a milliohm range, well, at 30,000 amps, you're still going to bounce up about 30 volts, which is enough voltage to do damage to just about any any receiver that's around, or any transmitter for that matter. The other thing too is that these lightning strikes, whether it's close to you or a little further away, that rising edge with that current flow is really fast. It's in the kind of sub-nanosecond range. So this creates a big burst of RF energy, and trying to reduce that current starts to become a problem with inductance in the just the plain inductance of the wire that's running to ground. Can be important, but if you've got any twists and turns and whatnot in your grounding cables, that can cause that 30 volts to be considerably higher than that. So how do you protect against that? So in a lot of reading, what I've discovered is that keeping the resistance and inductance as low as possible is a really good start. You're still going to be probably 30 to 50 volts of bounce in there. So the second thing that you need to do, apart from trying to minimize the problem, is to develop a strategy so that when the ground voltage actually bounces, all of the equipment and the operator, yourself and anyone else who's around, bounce exactly the same way at the same time. So there's never any great potential difference between ground references. And that, of course, is considerably easier said than done. A number of companies have suggested systems for how you might ground and for protection, and a little bit for RF interference. This particular one I stole from a vendor, but essentially their suggestion is that a couple of things. First of all, your antenna, it needs to be physically connected to ground in some fashion. So whether that's the you've got a Yagi up there that has a short in the center instead of an open in the center down the elements, or you've just bridged the framework for the antenna to your coax with a little bonding strap. In any case, if you can get some ground to that antenna, you'll reduce the noise that happens with airflow causing static electricity. But down at the bottom, the recommendation is that you put, from the base of the tower, radials going out with ground rods at specific distances apart. And those radials should go all the way out to the guy wires, and in fact tie into the guy wire system when you get out here close to the edge. You should also have a bonded grounding from the ground system that you've created here at the base of the antenna. You should have a ground wire, whether it's a wire on its own or the extension of one of the radials, right out to where your shack is, whether it's in the house or in an outside building. You'd want a perimeter ground around the shack to try and keep things from bouncing. And you want a really solid strap to a ground window inside the shack where all of your gear gets tied directly to that. So very important to have a single point ground in the shack so that everything moves together, and then tie that ground back to the ground at the tower so that if the stuff that's coming in your coax has a voltage bouncing on it, then whatever's causing the ground out here to bounce, your shack bounces along with it, and the difference, the potential between those two different references is negligible. One of the things worth noting on this picture too is that there seems to be an awful lot of ground rods, if you like. These dots represent rods going down into the ground. But of course, there's no scale on this drawing, so how far apart are those rods actually? Turns out that the distance that those rods are apart is actually relatively important. So, if you look at this sphere of influence graph up here, if I put my 10-foot copper pipe down into the ground, its impedance starts to reduce, starts to reduce, starts to reduce. And when you get out to about 10 feet away from that rod, it's effectively non-existent anymore. So, you would want these rods to be, maybe 20 feet apart in the worst case. If they're less than that, you start to get overlap between the two different ground rods. And if you put two ground rods in the ground 5 feet apart from each other, you might as well not bother. One ground rod gives you exactly the same impedance to ground. You need to get those rods a minimum of 8 feet apart. You also need to get them on the order of 10 feet deep. You should dig a hole that's approximately 1 foot by 1 foot. Hammer the rod into the bottom of that hole, and then you can have copper tubing or strapping going from that ground rod, towards the tower or towards the next ground rod, buried in sort of 6 to 12 inches of dirt. And then of course you can fill these 1 foot by 1 foot holes back in again when you're done, or leave them open in case you need to access those connections at a future date. Better if you fill them in, but not so much so that I would discourage you from actually filling them in. When you bring these radials into the base of the tower as well, it's not unusual to have dissimilar metals. And of course, dissimilar metals can react with each other, create corrosion, create oxidation, which is insulating, and so on. So it's very important that if you have dissimilar metals between the tubing or the radials that are going out and the actual tower itself, that you need to take care of bonding appropriately. That could involve welding. It could involve the types of clamps that sink into the copper and sink into the metal of the tower, into the steel of the tower, in order to create a connection that isn't going to oxidize or react from the two different metals. And it's important to connections to the ground and so on, to in fact make sure they're soldered and not just twisted together. By the way, I'm if anybody has any questions on stuff as I'm going along here, feel free to interrupt me.
Charlie, maybe you could just click the little hide thing. It's covering over some of the text on your screens at the bottom. We're beside the stop sharing button.
Oh, I see the hide. Okay, there we are. Thank you.
Yep,
I didn't realize that was there.
Yeah, thanks.
All right. This is I essentially stole material for this presentation from a number of sources. This chart I stole from the National Electrical Code Safety, the NFPA 780. And so it talks about a communication service, whether it be telephone or internet or whatever, with a gateway. In this particular case, it's an internet service, perhaps coax or whatever, that provides internet into the home. But same is true of the of your Radio Shack. It will have its own reference ground, and the AC power lines coming into the house, the service entrance will have its own reference ground, and it's really critical to tie those two together in some fashion. If they're on opposite sides of the house, then put in place a bond wire. Better yet, have them, come into the house in very close to the same area. Same with your radio, and then you can tie them together as they come to this single ground reference. But in any case, you don't want these things to have ground references that potentially can, um, during whatever event is going on, bounce and be at different potential from each other. That's a recipe for breaking your equipment and possibly breaking yourself.
Charlie, if you don't mind questions as we go, is that okay?
Yeah,
Peter,
absolutely.
Yeah, Peter, go ahead, please.
Are you muted, Peter? I'm not hearing anything. Hello?
Peter, you're muted.
Yeah, Charlie, I just wanted to add in just a practical experience I had with the bonding between building grounds and your service entrances and whatnot. Back in, I think it was around 73, 70, maybe 74, can't remember exactly. We had to measure the ground pins that were in the tarmac out by the old Terminal 1 to the building grounds. And it's so far back, I really can't remember what voltages we were seeing, but they were substantial. So it was obvious the ground pins were not bonded to the frame of the building ground of the terminal, and it was probably one of the reasons why that DC-8 had burnt to the ground over on Terminal 2 back then. But anyway, was some practical experience there. So if you touch the two together, you might be in a little bit of pain.
Yeah, absolutely. So that having some kind of bond wire to try and keep them at the same potential is really kind of critical. So folks, I can't actually see. So if someone puts their hand up and wants to speak, you'll have to interrupt me.
Yeah, I'll let you know. Drew just put his hand up. So Drew, please go ahead.
Yeah, Charlie, in practical terms, if I was to measure a voltage between, say, my station ground and the ground of the house, what would be, millivolts? What's an acceptable number? Because it's never going to be zero, right?
It's true, and I guess the answer to that is it depends. What equipment are you using? How sensitive is it to extraneous currents coming into it? Certainly you don't want something in the order of tens of volts,
Right.
but if you can get sub a volt or two, I think you're probably okay.
Well,
But
there's a reason I'm asking, and that is because I have measured around that, and I thought, oh boy, okay, well, what's the significance of that? And you've answered that. I mean, that puts it into perspective for me, anyways.
Yeah, a volt or two isn't going to give you a big shock. However, it's
No.
not going to make your radio very happy.
Well, actually, it was in regards to avoiding noise. So we'll just leave that for there. And I appreciate that, though. That's good.
And Hassan has a question for you there, Charlie.
Sure,
Yeah,
Hassan.
Yeah, just wanted to add on to Drew's point. The Earth has a surface charge of 100 volts per meter upwards. So if the elevation of two parts of your lawn are a meter apart, higher, you should see 100 volts on there. But of course, when you connect them with a wire, it'll go down to zero, or minor, like whatever, zero divide.
Right.
And the whole lightning thing is because light travels at 1 foot per nanosecond.
Mm-hmm.
So if the distance between your antenna and the shack is 100 feet, there's 100 nanoseconds during which it'll take 100 nanoseconds to equalize the voltage. So that's when you see the transient, and that's the duration over which you will see this potential difference.
Yes, so important to have some sort of protector for those sorts of things that operates quite quickly. In the telecom industry, we would use carbon blocks, which are kind of slow actually, but gas tubes are a pretty good protection. But to be honest, if you get a direct hit on your tower with a lightning strike, Safety is your concern. Your equipment's probably not going to survive, no matter how hard you've worked to get all this stuff exactly right.
Oh, that's right. So yes, I think there's another factor, which is the field of the Earth's surface charge directs the field upwards, but when a storm cloud passes overhead, it has a field of its own, which is kind of circular, and so you'll have a horizontal field, even if there's no lightning. And that horizontal electric field is what causes currents to flow in conductors.
Yeah, it's fascinating stuff. Like I say, this is probably one of the deepest rabbit holes I ever started to get into. Had to
Yeah.
kind of pull myself out and just do a relatively high level thing here.
I did have a question though. 2 slides back, you showed the
Yes.
antenna with the coax on top,
Yep.
and you mentioned that the coax should be bonded to the ground antenna tower and the ground. So, does that mean you have to have a bell in there? Because
Um,
yeah.
if you're doing things properly, you should have a bell in there anyway.
Mm-hmm.
There are no antennas up here that are 50 ohms. If it's a dipole, its fundamental impedance here is um, it's a balanced 72 ohm. So you really should have a balanced to unbalanced converter and a transformer to take it to 50 ohms at that point anyway. And I have a chart on that a little later on, but having it grounded up here helps you with static discharge. And you also want to ground it at the bottom as well, and then ground it again as it's entering your shack. More charts on that in a couple of slides here.
Okay, it's just that usually the cheap way to attach a coax to an antenna is ground on one leg and interconductor on the other. But if the ground is grounded, then it wouldn't radiate on one leg.
Yes, that's true. That's not exactly good practice. I mean, as amateur radio folks, we do that stuff all the time. But here, let me a couple charts. I'll just pop along here for a second. Yeah, this one, and then I'll go back again. So if you do that, where you stick, one side to the shield on the outside and the center conductor to the other side of it, you'll create common mode currents that flow on the outside of the coax. And in fact, if you model this kind of poor practice in like EasyNet, you'll see the radiation pattern. One side is radiating nicely, the other side significantly less energy radiating from it. And in fact, a lot of it is down the side of the coax heading back to the shack. This is the common mode current. It's the sort of thing that you need to try and avoid. And to be honest, like this is just very poor practice. You really should have a balun up here.
All right, thanks.
So I'll go back up here. Okay, so we talked about the ground bond wire between grounds. So in summary, if you've got a tower, you want a large number of ground rods. You need to have them appropriately sized and distance apart, at least 8 feet apart. Putting some type of surge protection on your coax is important. The ground rods absolutely need to be bonded together. As I mentioned, correct spacing of those rods. The ground wire size needs to be fairly substantial, something like a number 2 or a chunk of copper pipe from the hardware store is what makes sense. Smaller stuff will increase the impedance because the resistance or the inductance of it just goes up with lightning strikes. Also worth noting, dissimilar metals can react if you're not properly connected, so you need to bond them properly. And having a single reference point for all grounds is absolutely critical for safety. When you come into the shack, um, you should have a large cable or a strap to that ground that we talked about that goes out to the tower. But it's good practice to put a chunk of copper, a copper bus bar, to become the kind of ground window for your shack. So no matter what equipment you've got, it would have one of these little pieces of wire, one of these straps to it, so that the radio and the antenna tuner and your computer and everything else you can think of all have this ground reference that's all tied together and will all move. If the voltage increases, it will all move together. And then that copper bus bar gets tied back to the ground, single point ground. Also, any cables from the antenna should go through a ground reference before they go off to the radios. So while it's not shown in this picture with the bus bar, these coaxial switches are in fact connected on the end of a similar bus bar. In this particular shack, they just happen to be a couple of feet away, and then there's a strap that ties to this one. So all of those grounds come to a single point before it goes off to the reference. QSL.net had a suggestion as well for grounding in the shack. They suggest a 1/2-inch copper pipe with hose clamps on it, and those hose clamps then connect to your gear with a fairly short strap of either braid or maybe number 12, or worst case number 14 if it's fairly short. And then that ground window, if you like, goes to the tower and to the grounding rods that are outside. You want these cables relatively short, and the reason for that is not just to reduce the resistance for ground bounce, but also depending on the frequency you're using, if these things are really, because they're tying let's say they're tying your transceiver to ground, they're really part of the antenna system. And arguably they're a second transmission line, if you like, where you've got energy going to the antenna. That energy, you need a closed circuit in order to have current flow, and that closed circuit is through ground. So if it starts to become a significant portion of a wavelength, because it's somewhat a transmission line or part of the transmission line, this can cause problems. Like a transmission line, if a quarter wavelength away, an open becomes a short becomes an open, and somewhere between those two, you'll have an impedance on there. So if I've got a quarter wavelength at the frequency I'm operating here, lo and behold, while I think I've got a short to ground, it in fact looks like an open circuit, and I don't have an RF ground at all. From a DC perspective, from a lightning perspective, I do have a ground, but from an RF at my frequency of interest, if this is a quarter wavelength, it might as well not even be there. So you want to keep those things down to on the order of a 1/10 of a wavelength at the highest frequencies that you're working at. Question, go ahead.
I have to find my mute button first. Thanks, Charlie. Really good talk, by the way. Very, very interesting. I've got a question about this slide. Now, you're saying that the braid, from the transceiver to that copper bus bar, needs to be, a very short distance, so it's not part of the antenna. Wouldn't the entire copper bus with the wire going out to the ground rod also act as part of the antenna?
It so since our buddy Einstein said everything is relative, it depends on what your point of reference is for your measurement. So if if we're talking about the antenna tuner, then yes, the bus bar between the transceiver and the antenna tuner, for instance, that distance is also critical. But if all of these things are referenced to each other, and then it goes off to ground, um, as long as everything here, all of the equipment in the shack moves together, then it doesn't matter if it's at 50 volts as long as everything sees that ground at 50 volts, right?
But RF, like the ground rod, is not a magical thing that soaks up RF, right?
Right.
So the wire, the length of that, where it says low impedance conductor, as short as possible, that conductor that's going to the ground rod, that conductor, wouldn't that become part of your radiating element? Just as, your coax coming down the side. And I realize there's no current going between, like in the case, your point about transceiver to antenna tuner, got that check, okay, because that's a path that the return current can take. But when it's radiating, isn't it going to try and radiate, use any, like a quarterish wave, any kind of resonant length of copper it's going to use as part of the antenna if it's just sitting there on its own, like a ground radio in the ground, right?
Yeah, no, you're absolutely right. But again, it comes down to what's the reference point for the measurement. So um, what you're speaking about is let's say the coax is going from the transceiver out to the antenna. If that coax is not tied to this ground bus, then you're absolutely right. The distance between here to the ground, and then from this ground rod off to the coax of the antenna to the tower, um, this whole section here that's the ground window is going to be part of the problem. So it all depends on where your point of reference is. So if I've got my coax coming into the building and I've got it tied here, right where the transceiver is tied to this ground bus, then no issue. Those things are going to move together, and it doesn't really matter what's happening because from its point of reference, it sees the same thing. But if they're tied at different places, you're right. The distance of the cable coming from that ground outside all the way into the bus bar, and then from the bus bar to the transceiver, you need to take that into account.
I guess I just thought of this now. If you're looking into that coax, or you're looking into the connection to the transceiver, okay, if the connection to the coax is a mop, it's resonant, it's connected to resonant halves
Mm-hmm.
of an antenna. I don't know the terminology. It's connected to portions of an antenna that's going to mop up the RF, it's going to soak it up. It's a low impedance for the, I don't know the terminology, but the RF will travel down that path. But if it doesn't, then it's going to choose the lowest impedance path. I'm probably using the wrong words here, but do you get what I'm saying? Do you understand what I'm saying?
Yeah, no, I absolutely agree. I think we're violently agreeing, actually, uh, on this particular situation.
Yeah, okay, thanks. No, I wasn't I wasn't disputing what you're saying. I'm just trying to visualize how this works. This is a very, very interesting topic too, Charlie. Very good. Thank you.
Thanks, Lee. All right, moving on. So this is one of the things that people typically do when they come to grounding their tower. They'll jam, in this particular case, 3 ground rods into the ground. They'll tie it together some cable, and then they'll tie from those ground rods to the legs of the tower, and they think they think they've solved their problem. So many things wrong with this picture, right? So the distance between the ground rods, first of all, is not nearly enough. You might as well just have one ground rod as having these three. The physical wires that run between the rods really should be buried. There's no reason for them to be sitting up on top of the surface like this. And you probably want to make them, if possible, direct, a little shorter. The loop doesn't really help you with anything. If you take a look at this, if you are able to zoom into this picture, you'll see that they've got a piece of copper wire that I believe is soldered at this point, but then it's just kind of wrapped around the galvanized here, and some tape to hold it down. That will be fine on day one, questionable on day two, and after it's been there a couple of weeks, there'll be a fair impedance between the tower and this wire. And then the coax and so on doesn't really have any kind of grounding or anything going on at the base of the tower. In this particular case, they're just zip tying the coax down one of the legs and then shooting it off to a chunk of conduit, which goes off and into the shack. So not an optimum solution here. Yeah, go ahead.
Charlie, I'm not sure if you mentioned it or not, but just looking at this picture, it looks like there's 3 ground rods there.
Yes.
And my experience is, or my understanding is, the ground rods should actually, if you've got 3 ground rods, they should actually be connected in, for lack of a better word, in series, not in a loop like they've done here.
No, you want to minimize the impedance to those from the tower to those rods. So, multiple connections are okay. Putting them effectively in parallel, or whatever you want to call it, you're reducing the overall impedance to actual ground. So nothing wrong with connecting them that way, the way they've done it here, other than they're too close together. And
because what I've done in past is, there used to be, the guideline was, if you measure 25 ohms maximum was what you had. You'd like to have less, but the building code will say 25. And if you're at that range or higher, then you need to drive another ground rod. And then those 2 ground rods are then parallel, are connected together, and then off to the service. And if your resistance is still above 25, then you bang in a 3rd ground rod, but you're not connected in parallel. And you're now daisy chaining, if you will, to lower the resistance. Anyway, I don't have a ton of experience on it, but I do remember pounding ground rods way back in my apprenticeship days.
Yeah, I got to tell you, 25 ohms for a lightning strike is massive, right? Like, 30,000 amps at a milliohm, that's 30 volts. So at 25 ohms, that's hundreds of volts, thousands of volts.
But that's what the building code says. But having said that, by the way, just as a quickie here, I did as Drew was talking a little while ago, I did measure my ground for the shack is within about 10 feet of the building ground. And I just measured my station ground to the hydro ground, and I came up with 170 millivolts. I always assumed it was 0. I didn't think it was that high. But anyway, food for thought.
Put a wire between them.
There is. It's like I said, I'm within about 10 feet, and I measured 170.
Yeah, so that suggests that the bond wire between them is not as low a resistance or impedance as it should be, right? So maybe loosen and retighten the screws, because there's probably some oxidation has built up between the clamps.
A couple bonding points, but anyway, food for thought.
Yeah.
Thank you, Charlie.
Thanks. So here's another somewhat ugly view. In this particular case, the person has hammered in a bunch of ground rods, but again, they're all way too close together. So one would be just as effective as the number they've put in place here. And then KV5R suggests, at the base of the tower, running all of your coaxes through effectively a ground window in order to reduce common mode noise. It also helps with the electrostatic discharge. It also helps with lightning protection and so on. But his attempt here is to try and reduce the noise that he's getting in the receiver. And this is a good thing to do from a protection perspective. It might help with your RF noise. It's going to help a little bit for sure, might help significantly, but it's not really guaranteed because, as we were talking a few minutes ago, the length of the transmission line, if you're a quarter wavelength or multiples of quarter wavelengths, it could be what you're hoping is a short to ground here would look like an open circuit. So you need to very carefully take a look at what a wave is doing on your coax when you're trying to reduce the common mode noise. So talking about RF protection, we talked about safety for a while. Ground is absolutely part of the RF system, as Dave was mentioning earlier. Cables going to the ground point are also part of the transmission line, and consequently, you need to pay attention to the transmission line impedances, because they change with distance. And again, as I've mentioned a couple of times here, short to ground looks like an open circuit a quarter wavelength away, and somewhere in between the open and the short, anywhere along its length, there's going to be an impedance, and you want to reduce that as much as possible. So if you can keep it to, on the order of a tenth of a wavelength, that's excellent. And at HF, that's reasonably easy to do. When you start getting into VHF and UHF, however, that's not in the cards. So you need to carefully take a look at the length of your grounding wire, calculated in wavelengths at your operating frequency, to make sure that you're an even number of half wavelengths rather than having an extra quarter wavelength there, which will give you an impedance inversion. What else is on here worth mentioning? Grounding the coax shield at the tower might not be RF effective if the cable links to the ground window and from the ground window to ground, as the point Dave was making, and from the ground window to the radio aren't correct. So having that coax shield grounded is going to help with static and lightning, but not necessarily with RF noise. I popped this chart up earlier when we were talking about common mode noise. The interesting thing is that this chunk of coax, well, you think it has two conductors, in fact has three, thanks to skin effect. So you have the center conductor sending out a signal. What's coming up the inside of the coax is the other part of our transmission signal, or RF signal, but then any reflections from the mismatched impedance here go down on the outside of the conductor, which behaves like a third independent conductor, and it will radiate. It will radiate all the way into your shack. It will mess with your computer. It's a serious problem, particularly with certain types of antennas. So if you've got something like an end-fed half wave, for instance, where the outside of the coax effectively ends up being part of the antenna. Some folks would call it a counterpoise. That's a topic for another evening, but the outside of the coax becomes part of the antenna, and that will, in fact, conduct energy right into the shack. So you need to do something to make that not happen. So what will work to make that happen is, these are some equivalent circuits. So if we have our antenna, we got the coax coming down, which presents a small impedance. And then we go to our ground rod, which represents a small impedance. Then we have the coax running from the base of the tower here through a coax, which has a small impedance, to ground inside the shack. And then from that point, the antenna goes into your radio, and the radio also has a ground reference. So if the impedance of the coax and the impedance to ground here are equal, I've just wrote small on both of them because I have no idea what the numbers are. But if they're the same, because we're talking voltages here, noise voltages, there'd be a 6 dB drop at this section. And if these two are the same, that's another 6 dB. So the noise that the antenna is hearing and seeing, the common mode noise that gets reflected, it'll be down 12 dB at the radio. So yeah, not too shabby. It does something anyway. But much better is if you can add some inductance to make a larger impedance on that coax. So something like an ugly balun, where you just take 20 feet of coax and coil it in a loop that's sort of 6 to 12 inches in diameter, or you actually get a common mode choke, or you get a chunk of toroid and you loop the coax through it a couple of times. That increases the impedance, so that if the inductance here is presenting an impedance that's, I don't know, say it's probably hundreds of times bigger than this impedance to ground, but let's say it's 10 times bigger. If it's 10 times bigger than this one, then that's an additional 20 dB of loss here. So we've got 6, 12, and 20, 32 dB down versus 12 dB down. You can really increase the effectiveness of filtering of the noise signal that's reflecting from the antenna here, with some kind of common mode choke between the tower and the radio. In terms of protection, again, we want to, ideally we would ground that coax at the top of the tower, ground it at the bottom of the tower, ground it as it enters the building, and then throw a protector somewhere in this path before it gets to your radio. Grounding the shield of the coax is more challenging than you would think. Generally speaking, you need to remove the outer shield, and you need to connect to the not the outer PVC covering or whatever material it is to get to the shield winding. There are devices that you can purchase that will kind of wrap around and clamp. This one's on a piece of hard line. But you can also, if you just expose the shield, you can just take some copper, wrap it around. In a perfect world, you would solder it there. If you can do that without damaging the core of the coax, and then very very short distance, run it to your ground rod. Inside the shack, absolutely important to have anything like your power supply and your transceiver, linear amp if you've got one. Have those grounds come together at the ground window. having to go any kind of distance. If the power supply goes off to the city ground and your transceiver and amplifier go to the ground rod outside, there's potential for a voltage between them. These things absolutely need to be tied together. So I showed you some bad practices earlier, a couple of good practice pictures here. This setup was put together by a friend of mine who a couple of years ago suffered a direct lightning strike on his tower. His insurance claim included televisions, computers, ham radio gear, modems, just all kinds of things in his house, stereo equipment. It was a very, very nasty problem for him. So this is part of what he did to hopefully never have that happen again. I mean, there's still a fair amount of risk. A lightning strike is a really hard thing to protect against, but if his next door neighbor gets a strike, this stuff will help him with that for sure. Because most of us would still be in a lot of trouble if there was a direct strike in the same block we live in. So what he's done is he's put a chunk of copper. These are surge protectors. They're multi-kV. His coaxes come down off the tower, run through this lightning arrestor, and then go off to the shack. This copper bus bar at the back that he has these things bolted to, comes out through a copper bolt, and that goes off to his ground window. He has a couple of different connections going to the same ground window. That's really just about reducing the impedance to ground. He's also, his signaling stuff, whether it's his rotor controller or various other pieces of equipment that has switches and relays and whatnot. All of that gear again is tied to a screwed down, clamped down to a copper bus bar, and that copper bus bar again goes off to the ground window. So in summary here, things common errors that you should try to avoid: not enough ground rods, more equals merrier for sure, but have them a reasonable distance apart. That was the surprise learning for me. Was I would have just hammered them all on the ground, and discovering that getting them at least 8 feet apart was important. That was a big aha moment for me. Another common error: no surge protection at the base of the tower or whatever your antenna structure is. All of those ground rods are not bonded together properly. That's another error that often happens. Ground wires being too small, get to a number 2, or better yet, a chunk of copper pipe. Bends in the ground wire too tight. I didn't mention too much of this earlier, but high currents, particularly with fast rising edges like a lightning strike, don't like to go around corners. So if you create a 90-degree bend, that introduces a high impedance to it. Try and make your bends as loose as possible, and also bends in your ground wire should always bend in the direction of the ground. If you bend it up in the air a little bit to go along and then down after that, you're looking for trouble. It should always either be absolutely flat or heading in a downward direction, never in an upward direction, any ground wire, regardless of where it's coming from. Connecting to similar metals, there's always going to be some action happening there. You need to bond that properly, whether it involves welding or a neutral connector that is happy with happy with both metals. Just you need to make sure that you don't have the opportunity for some galvanic action there. And another common error is, grounds at multiple places. You need to tie those all together. The best thing you can do is creating a single point of ground, so that if you do get that thing bouncing because of high energy stuff, all of your equipment, your personal body, everything bounces the same way, so that the reference between you and gear or gear and gear is effectively 0 volts or a very small number. That's it for my presentation. Yes, sir.
Charlie, that was great. And I think I hit pretty well every point on your last slide, which always, it's nice to know that I'm hitting every one of the errors. I have a couple of products here, and I haven't tried them yet, but there's something that I purchased. One is called Copper Anti-Seize by Permatex, and the other is Oxguard, which is for aluminum to copper. And I was wondering if you've had any experience with using anti-corrosives in this regard for bonding. Given the fact that it's unlikely I'm going to be able to use thermite to join my copper to my rods and stuff because the neighbors frown on it. I'm just wondering if you had any luck with the you can't use axle grease, right? That's not going to work. But this copper anti-seize is given to me by the power line guys at work as a suggestion. I just wondered if you had any experience with it. Is it going to cause more trouble than less?
I have zero experience with it. I really don't know. What I have done in the past is, file and sandpaper to get everything nice and shiny, clamp it together, and then cover the whole thing with dielectric grease.
Yeah.
That's been my kind of go-to solution. But even that, every couple of years, pull it apart, shine it up again, and reconnect.
So number 2 wire for join, you would recommend at least number 2 for joining ground rods together?
That's what was recommended on a number of sites that I poked at.
So coming from my station, from the radio, I have a 1/2-inch copper pipe. I have this little tiny braid. I think it looks like steel, or anyway, it might be aluminum, it might be solder covered copper braid. I'm not sure. It's about 1/4-inch strapping that is commonly used. So that comes from the radio to the copper pipe, and then from that, I go out the window to a ground rod, which is kind of what the ARRL document showed, but mine is less robust than that. Would you recommend running a number 2 conductor out of the shack to that ground rod?
Number 2 is brutally expensive these days. I would use 1/2-inch copper pipe.
Yeah. But
the RF stuff, with skin effect, the RF energy and lightning in the beginning of the lightning strike and so on, that is an RF effect. Really, it's going to be skin effect is what rules here. So whatever current is flowing is going to flow on the outside of the conductor. So that number 2, there won't be a whole lot going on in the center of it. It's all going to be on the outside edge. So you might as well use copper pipe and save yourself some bucks.
Fair enough. Okay, thank you. I really appreciate it. A great presentation.
Thanks.
Okay,
Michael,
I think that's it for hands. Oh, well, Michael, yes, sorry.
Yeah, Charlie, thank you for a really good presentation. Very interesting. I've done some of the things that you've done, I think, as you're talking about. I'm not quite sure what to do about all the rest of it, given the particular circumstances I'm in. But one of the things you mentioned is grounding a power supply. Well, I have my HF transceiver connected to an Elenco power supply. And that power supply does not have a ground wire there's no ground connection on the back of it. If I connect the negative terminal of the power supply to ground, is that the same thing?
Sort of. So that Alinco power supply probably has a three-prong plug.
Yes, yes, it does. Exactly.
Yeah. So that third prong, the protection prong, is tied to ground, is tied to hydro ground. So you want to make sure that that hydro ground is tied to your radio system, and the negative voltage that comes off that power supply um, is, for your radio, um, that tying that to the ground rod is perfect. That's going to help for the radio. It's not going to help the power supply. The power supply might get damaged when some energy comes down your coax. So that third prong, which goes to ground, suggests that hydroelectrical ground should be tied into your ground window. If you got a copper bus bar on the back of your bench that all your gear is tied to, the negative supply from the Alinco should be there, and the hydro ground should be there as well.
Okay, I think I understand what you're saying. Um, my situation, I'm on the second floor, which of the house, which really complicates things as far as I'm concerned. So
Yes.
I think I've done the best I can, but that's so the power supply, the third conductor, the ground conductor, is of course connected to the hydro line, but I'm not sure how I would have to think about how I would tie that to the radio ground. I'm not sure how I do that, but okay.
One of the things
Well,
I
thank you very
did,
much.
one of the things I did actually is I bought a new plug for an extension cord, and didn't connect either of the power or the return at all. I just connected to the ground pin, and then I plugged that socket with just the ground wire into the outlet that my computers and other things are tied to, and then bring that wire to my ground window.
Okay. Thank you very much. Again, an excellent presentation. Very interesting.
Thanks. I think Joe has a question.
Yeah, I do. Yes. Actually, Charlie, I think this is actually more directed towards Michael. Michael, the power supply that you have, is it the DM330MV?
Yes. Hang on a second. How I look. Yes, the one I'm using for my FTDX is a 330 MV. That's right.
So where the fuse is at the back, this should be
yeah?
your ground. This should be your ground right here. It's
Okay,
not
I haven't
marked.
looked. I have another one. I have the one I looked at to check is 330 FX. So I'll check and see. So if there's a ground wire there, if there's a ground connection on the back of the 330 MV, I should connect that to my ground bus. That makes sense. Okay.
Yeah, that's all.
Okay, thanks, Joe.
Yep. That's it for me, guys. Thank you.
All right. I think that is it for hands. So yes, thank you very much, Charlie. Great presentation. Lots of information that I think we'll be referring back to, especially some of those diagrams that you had there. So definitely some good food for thought. I did post a YouTube link, not to steal your thunder, but in the chat there, I just came across on, I think they were discussing it on a podcast, but at the last ARRL convention back in May, there was a talk by the vice president from ARRL about grounding. So something else that you might want to have a look at, and you can never have enough information in that regard. Of course, is it Ward Silver, I think, N0AX, who has the I don't know what edition it's in now, at least second, if not the third of his grounding and bonding title, also from the ARRL, which is a good reference. So all right. So we did have one of our speakers, upcoming speakers, on briefly for a test run of Jitsi, but it's another Dave, VE3KCL, but he has not returned back. He had briefly winked on, even though I missed him. But Peter alerted me to the fact that he was here. But if anyone happens to see him come back on, please highlight that to me if I miss it. So it is 10 to 8, sorry, 10 to 9. We've got a little bit of time left if we'd like to go around and do a round table. So, Dave, what's new with you?
Good timing, because I was just about to drop off. I'm kind of time limited tonight, so I could give a quick kind of discussion of what I'm doing. Is my audio good? People are saying
I was just going to comment on it. It is not good. It's nowhere near its usual quality. It's quite.
Cause my camera died last week or last meeting, and so I had to go rummaging around trying to find another camera. So the camera I've got is a cheap piece of crap. Yeah, and that's why the audio is off. And that's how I managed to stumble across my Palm Pilot and my old Windows CE telephones from way back when.
You're quite understandable, Dave. It's fine. It's just not stereo quality.
Your skin looks like a 20-year-old now, so you know. But no, you're peaking. Like there's a lot of you're clipping, I guess, going on with your voice. It's or you've whatever, or you've had too much whiskey. One of the two.
No, the camera's pretty close to me. It's a cheap camera. This is like a 320p camera, so it's kind of crappy. Yeah, there was something I was going to mention because I just so I've been doing a lot of things. I'm mostly working on my Z80 computer, and one of the things I stumbled across my Palm Pilot and started playing around with that a little bit. Won't go into that. But the interesting thing is that I had two Arduino Nanos that are dead, and I wanted to fix them, and I had replacement chips for them because I need another Nano for my Z80 because I'm gonna. Long story, but anyway, so I soldered the chips to the board, and you guys should. This is very, very, very important for anyone who's going to be fixing an Arduino that has the 328, the Atmega 328 chip. Okay, the chips you buy could be 328 Atmega 328 PB. The Arduino Nano and the Uno and all the other chips it's made from the Atmega 328P. The chips you can get is a PB, which is a totally different chip. The pinouts, it's got, I think, 3 or 4 pins that are different. So I soldered one. I had 4 of those, thinking, hey, I got replacement chips. I soldered one in, tried to load the bootloader on it, and it wouldn't work. It kept giving me an error. Finally, when I looked at it, it said it was a PB. Anyway, to make a long story short, I finally managed to get it to work. It's a pain in the ass. If you're buying at Mega Chips, make sure you buy the exact part to what is on the board. Exact part. Even though it's a Atmega 328 PB, it's not an Atmega 328P. Anyway, enough said. Next.
I have a question though, Dave. Like, why would you fix a Nano? Aren't they like $5 to buy one? That'd be like re-bristling your toothbrush or whatever.
Yeah. The chip, you could go and buy them. They're like $1 to go and buy it. And I don't like going out because what am I going to do? Perfectly good Nano, and I'm going to throw it out in the garbage? Yeah, sure, it's cheap enough. Just go buy another one. Hey, we're hams. We're supposed to fix shit.
Okay, well, I've got lots of stuff for you to fix if that's the case. So, lots of stuff.
And you know you're saving probably on the order of, it's like getting paid 50 cents an hour, right? Doing that.
Anyway, I gotta drop off now. I can't stick around to listen to other people. But hey, Charlie, man, fantastic presentation.
Ordering little packages of parts for projects I intend to do in the winter, and one of the ones that I've recently purchased, I entered the Bell Fibe world. My copper lines had so degraded to the point where Bell told me they would not fix them. So I let them put fibe in my house, and now none of my phone collection works because they're all dials. So, of course, enter the world of Instructables, and I found a really cool little AT Tiny 85 device to turn pulses into DTMF. So that's what I'm currently playing around with, is to turn my dial phones into touch tone on my own, just to see if it's going to work. And I'm not betting it's going to work, but I've got to give it a try because I got a bunch of dial phones. So that's my current interest.
All right, sounds cool. If you get it to work, I'd be interested to see how you made out with that. I've got.
If I get it to work, I will call you on my candlestick phone.
Oh,
Yeah, Eric, you probably got about 15 or 20 of those phone dial-ups.
I do. I have Erico phones. I have, British phone. Yes, I have lots. The one phone I'm not allowed to use, and they told me this, was the one with the crank on it. Apparently, if you hook it up and you turn the crank, it causes problems downstream. This is what they tell me, is that it's a bad thing to do.
Why did you have to turn a crank on the phone? I know they exist, but what was the purpose of that?
To ring the bell on the switchboard in your house.
To let them to wake up the operator.
It creates
It creates
between 90 and 100 volts of AC,
it does.
which
fact,
which rings the bell at the other end. So you had a phone connected to a phone with a pair of wires between, no operator, nothing in the middle, and when you turn the crank, it rang the bell at the other end.
So Eric, you have a switchboard.
I do, yes.
So if we hook up our wires together and I turn my crank, your bell will ring.
Oh, I see the genesis of a collaborative project here. Yes, indeed.
It's like Laura with wires. It could have our own private cell network.
I'd be very happy to be part of that. I have one expertise, which is I was a recognized expert in one area that's completely obsolete now, which is wireline telephones. So I'd be more than happy to dive into that project with you guys.
Really? So, like, if I have trouble with my switchboard, you're the man? Yeah,
absolutely.
He is absolutely the man.
Oh my goodness! I think we're going to have to start the second Wednesday of every month. Yeah. Okay.
Time to get another sea container.
Yeah.
Just make sure to ground your telephones, though.
That's right.
Taking all the fun out of it.
Excellent. And then the fourth Wednesday will be the theremin group. So
yes.
I'm waiting for him to. Yeah. Okay. No. Not enough for him to actually hang himself. So.
Anyways, that's what I'm working on.
They're 100 meters, 200 feet, actually a kilometer away, but they took it down. So that's the one we all took down. So there's nothing of interest. I'm more worried about lightning. That's why I don't do anything on the roof. But I guess that's still a concern, I suppose, because the home insurance will probably not cover anything if I get a strike or anything.
If you're a RAC member, you do get some insurance. But the thing is, if you're interested in scanners and SDRs and the like, why don't you put a discount up there?
Oh, I'd love to. But do I need to worry about grounding for that?
Charlie?
Sure, but it's a protection ground you're dealing with. If you're playing with scanners, the frequencies are going to be such that as an RF ground, you're not going to get much value out of it. So I would think of it as a lightning protector. I'd run a chunk of wire down the side of the building to a ground rod and call it a day. That should be fine.
Okay, and disconnected at all times when not in use?
Yeah, I mean that's well, certainly all times when you think there's nasty weather coming in. I
Okay.
That's what I do, to be honest. And my buddy who did have the ground strike has invested an awful lot of energy in grounding and protection devices and all kinds of stuff around his tower and his house and so on. Once bitten, twice shy. He still disconnects everything when there's a storm forecast coming in.
Eric, I think you need to make a lightning trauma survivors group.
Got a couple of members for you for sure.
Right. Okay. Joe, you're next on my circle here.
Okay, actually, just a quick aside to Hassan. Hassan, this is another thing, just completely aside from amateur radio. If you got roofers going in and redoing the shingles and whatnot, after they're done, don't park your car, in the driveway right away. Really sweep that sucker up, because there's going to be roofing nails all over the place. I guarantee you. I just went through that experience a couple of weeks ago. So anyway, that's an aside.
Oh, thank you.
Yeah. On the amateur radio side, well, not so much amateur radio, but you guys know, I know I'm working with Meshtastic, so I was finally able to get back into it. And just last week, what I was trying to do was I was trying to get a water leak sensor working on a Meshtastic node. I finally got that running. So I got it was a Raspberry Pi with a WaveShare hat on top of it. Sorry, a Raspberry Pi Pico with a WaveShare hat on top of it, and one of the available pins that you can use for GPIO that's not used by the hat was GPIO pin 5, and I was able to put the water sensor on there, and the Meshtastic software allows you to designate a GPIO pin that you can monitor, whether it's high or low. And I was able to get the water sensor to work off of that, and then that Pi Pico was able to transmit over Meshtastic, saying, there's a leak, there isn't one. And I was able to transmit to another device. It's one of those LilyGo TTGOs, those little mini guys that work with your phone. So I was able to get the transmission from the Raspberry Pi Pico that, yes, there was a leak, no, there wasn't. So I got that bit working, and that was on a channel that I created between the two devices. So my next step is I want to now include one of those MQTT servers. So I think you've heard before, guys, there's a thing or a setting called an MQTT server. That you can think of that as like Twitter for devices. And so what happens is that the devices can send short messages to this central node, and it creates channels. And the channels, you can subscribe to a channel or you can publish to a channel. And that's useful because usually MQTT nodes are connected to the internet. So your sensor network, you can connect via, Meshtastic and LoRa. But if any of the devices also tap into Wi-Fi, that device can then, take whatever telemetry, throw it over to MQTT, and other devices on the network can then see what's going on with the sensor network. So that's my next step. I'm going to be putting an MQTT server in play, and then I'm going to get the Raspberry Pi Pico not only to transmit on Meshtastic, but whatever status change it sees, also publish to that MQTT server. And then I'm going to have an app on my phone, have a dashboard to see whether or not it sees the leak or not. right, through the network. So once I've got all those pieces in play, Peter, I think I can do a presentation on that at that point. So that way you guys can see all the basic pieces in play. And then because incorporating all those pieces, you see basically how a lot of these other LoRa networks work. And I can also show you the settings of what's done on Meshtastic to make it go. Yeah. So hopefully I'll have word by next conference that we have. Yeah. That's it.
Okay. All right. Thank you very much, Joe. Appreciate that. Yeah, looking forward to that on the heels of our Meshtastic discussion we recently had at a prior meeting. So that will be interesting. I just actually came across the Meshtastic card that I got from the Hamfest, Central Ontario Hamfest, where that fellow talked to us. So good stuff. All right, Peter, you have the floor.
Okay, thanks, Eric. And okay, great, Joe. Well, we'll be in touch. Actually, I got enough presentations. I'm going to actually start assigning them up into the January. So we're doing pretty good. I finally got a design for my active probe that I was happy with, or at least can move to the next step. So about 4 days ago or so, I ordered some boards from JLCBCB for the active probe. LT Spice says I got a winner, chicken dinner. So we'll see what happens when the board comes. The board's got some pots on it, trim pots on it that wouldn't be on the final version, but they're just to play around a little bit with the op amps adjustments there, just to fine tune a little bit if necessary. And yeah, so that's pretty much all that's been going on in this shack. And then I can hardly wait to put this one to bed so we can figure out what we want to do next. Anyway, that's it for here, Eric.
Okay. Thank you, Peter. Michael.
Yeah, thanks. Just as an aside for Hassan, when we had our roof done years ago now, before we had it done, we had problems with ice dams, and I presume you know that what you can do is get a 3-foot wide membrane, and they run it along the edge of the roof where the eaves troughs are, and that protects you from ice dams, from ice buildup underneath the shingles. I presume you know about that, but you can get those anyway. As far as what's going on around here, in connection with what Charlie was saying, the one I have the very similar panel to the one you showed with the with the copper plate in a box and a bunch of Morgan arresters for the various antennas, for the HF antennas and the VHF antenna, and I also have the same isolation things for the rotor controller and the antenna switch I've got. As far as and for what it's worth, I don't know, maybe 5 or 6 or 7, 8 years ago, there was a near strike to a tree on the boulevard, which is probably, I don't know, 75 feet away maybe from my tower. No damage to the radios. We did lose a VCR and something else, I forget what, but no damage to the radios or anything, so I was very lucky. As far as what I've been doing, not much. I did finish my antenna switch. Finally, it works. I'm very pleased with it. And now this was the prototype. It's in a box, and now we're going to build another one for Daniel VE3NI. And in terms of haven't been doing much else, one of the things I'm looking into is I borrowed one of Wayne's isolation transformers, and I'm not sure I really am happy with what I know about those, so I'm going to do some more investigation in that. And the other thing I seem to spend time doing is looking in my shack for stuff. I couldn't find, I wanted to put some power poles on, and I couldn't find the little connectors. I eventually found them in a box somewhere, but it's a nightmare. Anyway, that's really all I got to say. Thanks.
Okay. All right. Thanks for the update, Michael. As far as myself, well, you all know what I've been doing since your monitoring cameras have been keeping tabs on my shipping container and all that. But I have a question actually, because I've been working so hard at straightening things up that I haven't been keeping track of the DCR messages. Where are we at with that? Does anybody have any information on that? Has anything changed significantly since we last spoke?
We're just waiting. We're just waiting for Kevin to finish off the
documentation.
Manual. And he said he was telling me earlier that he's almost complete. And I think that's it. But the last conversation I had with Ken, I think that's what it was. But we'll have to wait till Ken comes back on board to find out for sure.
Right. Okay. All right. So yeah, other than like I said, unearthing a lot of my ham gear and getting it consolidated, not too much going on. It's cleanup mode for me. So, but what is coming up in just over a month is 4 days at our cottage. So I will again. I know I've said I'd do this, but I haven't yet put out a posting about it. But now that we're already into October, the time is of the essence. So it's from November 6th to 10th. I'll post that and get that on everybody's schedule. So, all right. So I think that's pretty much it. We're already 9:15, so I think it's time to wrap this up. So our next meeting is next week on the 9th for the plain old telephone service switchboard group. Then we have our regular meeting on the 16th, and then the Theremin special interest group on the 23rd. So I look forward to seeing you all on the SOAREX Jitsi site. Well, come ye, come all. So I know there's one person that'll be holding his breath. So maybe putting a bag over his head first before he holds his breath. I don't know. There he goes.
Not unlike the ukulele orchestra, I see a theremin orchestra in your
I'm
future.
going for a whiskey.
Okay, gentlemen. Thank you for attending, and have a great night.
Okay. Good night, everyone.
Yes,
Thank you,
again,
Charlie. That was really good.
Charlie.
Thank you so much. Thank you, guys.
Excellent talk.
Thanks, everyone.
Take care. Bye.
Good night.